Hey, good afternoon. This is Darren Riley here with IAC Acoustics. Sorry, we had a few minutes elapsed there with some technical difficulties getting logged in here. So, again, Darren Riley with IAC Acoustics. We are going to present the HVAC product and systems here. So, good afternoon. Let's dive in here. We got about a half an hour to cover a lot of territory. IAC Acoustics is a Catalyst Acoustics Group company. The Catalyst Acoustics Group, actually known and nicknamed as CAG, is the parent company of an elite group of acoustic, seismic, vibration, and noise control companies that together offer the broadest portfolio of noise control solutions in the market today. Again, IAC established back in 1949 there on good old Jackson Avenue in the Bronx. Martin Hirschhorn then went on to expand IAC into a larger facility with an acoustics laboratory there on Commerce Avenue. So we have today the IAC Acoustic sales team is Tom Hines. He is our national sales manager, 19 plus years of IAC experience. Myself, Darren Riley with IAC Acoustics, HVAC product sales manager, 17 plus years of industry and IAC experience here as well. Today, presentation topics. We're going to cover duct silencer, acoustic louver basics, HVAC duct silencer products, louver products, our online tools, the IAC Virtual and Snap tool, application and installations. You'll see some pictures on that, duct lagging and quiet vent products and material, and then question and answers. Typically, what I leave that on there just to say, hey, copy my email down, shoot me an email or give me a call, and we can do some one-on-one Q&As if need be. So what makes IAC Acoustics superior to the competition? A few things here. Strategically located manufacturing facilities in major markets, which helps to minimize damage to shipments. We try our hardest to make sure every shipment arrives in good working order, reducing shipping time and also reducing and lowering freight costs. One of the things that I love to say is that we have the industry-leading quick ship program that any of our competition can match today still. We have a 5-day and a 10-day lead time options for all of IAC's full product line. No other manufacturer offers such a broad option for accelerated deliveries at all. Another thing is that IAC sound attenuators and acoustic louvers are manufactured in the USA, and IAC is a U.S. company. 100% of IAC success feed local economies and U.S. businesses. So again, basically, we are 100% IAC invested in the USA. Broad range of union affiliations here as well. In the New York Local Union 28 market, which is one of the larger markets there. We also cover the International Sheet Metal Workers Union. So we can fire off and have a blue label or yellow label. So we also can do non-union fabrication as well. Reliability and consistency. For over 70 years, our name and our brand has stood for reliability, and our HVAC noise control systems are part of this heritage. We also focus on solutions that are developed from standard models and configurations. As consultants, engineers, and contractors and owners, they always know what they're going to be receiving. We also serve both the construction markets and the acoustical engineering community. And again, we have the broadest product portfolio in the market, including a full range of sound attenuators, multiple acoustic louver profiles, packless silencers, elbows, pipe and duct lag, transfer vent silencers, and our ever now most popular PowerFlow heavy gauge fully welded silencers. So with that, let's dive right. Let's kind of show here our tools, which we'll cover here just a few minutes. Our IAC Virtual Silencer Louver tool. This is a great tool. It is a cloud-based tool. So again, you do not have to actually download it to your website or to your desktop. You can use this at 33,000 feet in the air, maybe 35,000. I have used it many times when I've been in an airplane traveling and or also on a train. So it is a quick select menu for prompting with processing and product selections. You have the flexibility to compare our products, IAC products, with also known alternatives, our competitors, customizable options and expedited results. You can revisit the projects, save it, and create submittal drawings, and it's also compatible with a smartphone and a tablet. Our other tools is our Snap tool. This tool provides basic silencer application assistance for airborne duct noise for sources to interior or exterior type projects. On a quick view, this thing is a great tool to do a full system analysis as needed. We'll do a quick one here to kind of show it as well. But it is a great tool to do a system effect. That way you can actually see, you can do this either in NC, DVA, or NR octave band results. Our duct silencer and louver operating principles. As you take a look at this picture, you're going to see that ventilation and air movement systems utilize ductwork and or silencers to route air from location to location. Here's another good picture of this. And again, noise, though, can easily be transmitted along with airflow, which we'll go over here shortly. Lastly is our conic pick. Silencers and louvers operate by absorbing sound as it passes through the silencer or louver while imposing only a minimum restriction on the airflow. Our duct silencer design. I like to go over this just because the simple effect is that you see on the left and then look on the right, they are the same. This is our solid round noses that help increase noise reduction. At the same time, it is a bell mouth entrance and exits, which minimizes turbulence, pressure drop, and self-noise. Case in point is that our silencers are rated for forward and reverse flow on either end, so it doesn't really matter which way you install this. We're also going to now cover face area, face velocity, silencer pressure drop, percent of open area, insertion loss for reverse flow, dynamic insertion loss, self-noise, and then we'll also kind of touch there on our film line silencer here as well, nicknamed our hospital grade. Face area and face velocity. When you're looking at the face area, that is width times height. So an example is 24 inches wide by 24 inches high equals 576 square inches. Convert that to square feet. That is then 4 square feet. Now, face velocity, though, is CFM divided by your face area. So 4,000 CFM divided by square feet, which is your 4 square feet, you have 1,000 feet per minute. I always say this because just to make sure, I've had some people kind of do it, but you make sure you utilize the square feet, not the square inches when you're dividing that with the CFM to get your face velocity. You will get a skewed number if you do. Aerodynamic airflow resistance. This is a unit of pressure at a given face velocity, known as pressure drop, or PD. It is measured in inches of H2O, inches of water gauge, at a given velocity, feet per minute. It is measured in difference in pressure upstream and downstream of a silencer and or a louver. There you see in red square the Bernoulli equation, so knock yourself out if you want to kind of do that. If you want some help, I'll be more than glad to go over some good calculus and trigonometry there with you as well. One of the nice things, though, is within our catalog, we actually have a great table, number 3, which is our aerodynamic performance. It shows the silencer face velocity at feet per minute in association with the static pressure drop there as well. Now you see that this is a model LFS. It is you see also the second column from the left, 3, 5, 7, and 10. Those are basically your standard, your typical standard lengths. So when you see like a 3 LFS or 5 LFS, that's 3 foot or 5 foot or 36 inches or 60 inches and so on. But do not hold us to that 3, 5, 7, or 10 feet. We can literally do any feet, anything, in any length that you need. So if you need like say 6 foot 8 inches or 9 foot 2 inches, we can do that. Now let's look at percent of open area. When you look at this, this is calculated 2 AP divided by width. Please note here that half the gaps and half baffle thicknesses are H and D respectively, and performance is based on these parameters. Now, take a look at the single silencer on the left of the screen. Now look at the 3 on the right, all having a different configuration. Now, when you look at this, though, all have the same acoustical performance of that of the one on the left, thus assuming H, D, and L are the same. So the number of baffles and air gaps only affects the flow area, as does the height and the span of the baffle. Having more baffle arrangements within the silencer, you will then have more flow area. You will then also have lower air gap velocity and lower pressure loss. Taking a look at performance considerations for positive, forward flow, negative, reverse flow. You can see up on the top there for forward flow, the fan is pushing air through a silencer, while on reverse flow, it is pulling air back through. Performance considerations for the acoustical performance dynamic insertion loss, also known as DIL. You can see there at the top, it has the cute little equation there as well. But here, this is the type of loss that would be different between the sound power or intensity levels measured in and at the same point of the ductwork before and after the insertion of the silencer. And this is also shown in the forward flow here as well. Another table that we do show in our catalog is our dynamic insertion loss. Again, this is our 3 LFS, 5 LFS, 7, or 10. But you can see here in the 8 octave bands, you can see it ranges from negative 2,000 to positive 2,000 for our phase velocity. Now, something to talk about here is our, I would say, performance consideration here. This is self-noise. Some silencers, when they're inserted, again, it depends. Now, again, 5 duct diameters up, 10 duct diameters downstream. That would be a perfect example, but we all know in job sites, and we do not live in a perfect world, these are going to be installed in different areas. So sometimes if it's closer to the actual, say, air handling unit or chiller or cooling tower, you might get some perforated noise. So that is interaction with perforated. So you might hear a little bit of the whistling noise. You might also, if it's really close, if it's like right underneath the actual air handling unit, you're going to have some entrance impact. The nice thing though is that with our bell mouth entrance and exit, with the entrance impact, it is minimal. The same thing with the discharge and separation for the turbulence. It is minimal there as well because the air passages are the same throughout. So literally you're going to have an even flow of air coming in and an even flow of air going out. Now, I will say this. Some of the competition on the discharge end of the silencer, it tails off. So air follows the path of what? Path of least resistance. Air will bounce off the side of the silencer and or ductwork as it leaves the silencer, and it will then start to rumble. So one of the things I will say this is that with our silencers, not only do we have some of the best performance out there for insertion loss, but we also have the most minimal impact of self-noise being emitted back into the system. Here's another example of source-generated sound. So again, if the fan, not the fan, but the fan is pushing air through, you might see some self-generated noise again through the perf and as it exits, but it's going to again kind of quell that as it follows the airflow. Case in point, in reverse, it's going to be pulling it to the fan. So again, the noise is after the silencer, not right there at the fan, not before. Again, another table that we show in our catalog is the self-noise power levels. So again, from negative 2,000 to positive 2,000, you can see the different results there for the 8 octave bands. If you need help on, say, doing some interpolation, say you're looking at a positive 650 or 750, let me know. I can help you with some doing some interpolation, things like that as well. Moving on to our product range. All of IAC silencers and louvers were developed in response to the specific requirements from acoustical consultants, consulting engineers, building owners, and contractors. Everything has been tested for performance. We provide the most economical choices for solving the wide variety of noise control problems encountered in HVAC engineering today. We'll kind of go through our product range here. You're going to see it through the Quiet Duct commercial series. That is basically like 70% of the bread and butter that's out there in the market today. We have our Quiet Duct Ultra Green and our Quiet Duct Clean Flow series, nicknamed our hospital grade. You see it uses the same basic nomenclature for the LFS and the UG Ultra Green LFS or the H hospital grade LFS. So in essence, these three LFS silencers will have the same baffle arrangement inside, the same open air passage and things like that as well. But with the Quiet Duct Commercial Series, it is filled with fiberglass only. Ultra Green is filled with basically the Ultra Green type material. It's 100% environmentally friendly type material. It is 100% cotton. It is dipped in an antifungal, anti-mildew solution. And it's also green. I will say this. I have seen over the years that the Ultra Green silencers, UG-LFM, UG-MS, and UG-L, have actually outperformed the LFM, MS, and L for the Quiet Duct Commercial Series in the 36 and in the 60-inch ranges for lengths, in the neighborhood of around about 500 to about 2,000 CFM. So take a look at that. It is around about a 5 to 7% adder, I guess, so to speak, because of the different infill material, but it does a really good job. Our Quiet Duct Clean Flow Hospital Grade Series silencers, if you take a look at this screen here, you're going to see this is kind of a standard picture where it shows the hospital grade film liner with the acoustical standoff. So you have the two baffles, and inside each of the baffles, you have the solid noses on the ends. You have your perforated. Behind that, you will then have your wire mesh. Now that helps to separate what is inside the heat-sealed polyethylene bag. Inside that, you will have your acoustical standoff, which is a standard honeycomb type mesh material, and your standard fiberglass. Again, all of that is within the 100% heat-sealed polyethylene bag behind the wire mesh, which is then behind the perforated material. We also have our Quiet Duct elbow silencers, which we can now do in hospital grade, Ultra Green, or even packless. So if there's a need for those, contact me directly and I can help you with those. And then we also have our Ultra Pals and our packless silencers. Down below is a really good picture of the inside of what it looks like in the elbow. Some of our competition likes to start out and they perform just straight baffles. Then they do one curved turning vane inside and come back with straight baffles. While that is easy to build, it is not a good performing type elbow. Our internal baffles also are the turning vanes themselves, which you can clearly see. Last but not least, we have our Quiet Duct Conic Flow silencer series, and then we have our D-Duct diffusers, nicknamed Dump Loft, for axial type silencers. These are great silencers where you're wanting to actually reduce, because they have, I guess, what is called like a negative flow for this, is literally you're going to take, say, a fan that has a static pressure of 4 static pressure. By applying the D-Duct diffuser on the inlet and outlet of a fan, you're going to reduce that down to, say, maybe 1/2 to 3/4 inches of static pressure. So that's why I typically say that these are good within themselves, and they are great on this here. And these are widely used with axial type silencers here as well. We also then have our Quiet Duct Ultra Low Series silencers. These actually handle the 31.5 octave bands. And then we have we still have it, and we're still pumping them out. Our Quiet Duct Ultra ZAPD, zero added pressure drop. You're going to see here that for W2 over here on the silencer, the 6, the 9, and the 12, that is the openings of the width only. You can stack these as high as your heart desires. But these are custom type silencers for those sizes of width only. So if you need help with these, contact me. I'd be glad to go over these with you. Moving on to our Louver products, you can see right here at our website, you can see where you can download our Louver catalog, specifications, and performance cut sheets here as well. The nice thing about Louver operating principles is still yet forward and or reverse flow in correlation with the sound source. Is our louvers are multi-purpose, permitting airflow in forward and reverse while shielding the environment from unwanted noise. Now, this is what you see up there is a representation of a model and our model LP louvers. Model R is a regular louver, LP is lower pressure drop. The blades are airfoil shaped. And again, at the intake and discharge of the louver, you're going to have 100% free open area. At the closest point, though, right in between these blades, these airfoil blades, it's around 18 to 20% free area. Because of the diffuser effect, though, on the discharge side of all of our louvers, however, you actually get a pressure regain, and the louver performs much better than, say, 20% free open area. Based upon our testing and analysis here with the AMCA and then also with the SL200, the Model R louver pressure drop performance is equivalent to a straight bladed parallel louver, roughly around 46% free open area. The Model LP louver, though, pressure drop performance is equivalent to the straight bladed louver with roughly 50% free area, because the airfoil blades and the splitter blades have a little bit more area between the two, so there's space a little bit more, and also the louver blades for the LP are also 14 inches from bottom to top instead of 12 inches bottom to top like for the Model R. So for example, if you had a 10-foot wide by 10-foot high rough opening at 50,000 CFM, your face velocity would be 500 feet per minute. The face velocity here would yield a pressure drop of roughly 0.27 inches water gauge for the IAC Model R acoustic louver. So some other manufacturers rate their performance based upon air velocity through the free area, whereas we rate based on air velocity across through the rough opening, in which case the free area is not required for the calculation of pressure drop. I will say this, a lot of people design a free area first. Design to performance first. Free area will end up being what it is. I will say this also too, that when you design a free open area versus performance, if a 10-foot by 10-foot rough opening is designed to performance first, and then free area is what it is, say at 46%, you want to make it 50%, literally you're going to have to make that hole probably 12 feet by 12 feet. So that's kind of what happens, the difference between free area and performance. Some different pictorials of what we can do with our louvers. They can be as acoustic louvers or screens, and they can also be integrated as doors or in the door itself. This is a nice louver screen wall. It's a standalone. This is actually on a children's hospital that we have done. And you can see on the left there, you can see some different louver installation supporting steelwork designs. And then we also show how to specify the acoustic louvers for the noise shield and for the slim shield louvers. Breaking it down, we have our Model R and 2R. The 2R is now a chevron look, 24 inches in depth. Same thing with our LP and 2LP. We have our SL4 at 4 inches in depth and SL6, 6 inches in depth. We also then have our SL12 and SL24. These are straight instead of the airfoil. And here's a nice little a comparison here between our Model 2R and 2LP. Same characteristics, same width by height, depth, same CFM. You can see with the Model R, that 0.25 water gauge, and the Model L2LP at 0.12. So if you need help doing some different calculations for your louvers, please contact me. I'd be glad to walk you through things. We have our dust collector silencers that you can see here as well. It's 100% turning vane up inside here, and then it goes into our the silencers here. You can see they're welded together. Here's another picture. You can kind of see how these are fully welded together. These are 10-foot MS type silencers for our dust collector there with PC&D in good old Atlanta, Georgia. We have our silencers that are banked side by side and then nested and stacked on top of each other for the Dyer Avenue tunnel. These are actually multiple banked silencers at 3 feet by 3 feet by 120 inches or 144 inches in length. Here's another picture of Dyer Avenue tunnel behind the screen. The Citibank building for the exhaust silencers. Yet again, multiple silencers. This was around about 30 feet in width. This was 12 feet in height, and you can see that these are banked. And then our waterfront substation here in Washington, D.C. here, multiple louvers tied together. You can bolt these side by side. You can bolt the bottom to the top. They have a nice louver framing system that they were actually just to bolt these two as well, creating a nice walled look, and also the door. And then up top as well, we were able to make all these as one. Our sound seal pipe and duct lag material, you can see that this is wrapped around duct. You can wrap this around silencers. You can also wrap this around pieces of equipment. So this comes in 54-foot rolls. It is a outer reinforced foil jacket with a mass-loaded vinyl noise barrier underneath, and yet underneath that is a quilted fiberglass decoupler. We can do this in a 1-inch thick quilted fiberglass decoupler or a 2-inch thick quilted fiberglass decoupler. You can see that it has really good, pretty STC ratings. The 1-inch at 29 and the 2-inch at 30. Last but not least, we have our quiet vent silencers, nicknamed crosstalk silencers. These are great from like room to room, or the military uses these if they're showing, say, a movie in one room, and the other room you have the CO who's kind of just literally letting everyone else have it, yelling. Not either, you basically want to kind of have the movie not going into the room, and you don't want all the yelling for one room coming into the room where the movie is. So these are great, and you can see for the type C, this is for the ceiling insulation. The type H is for exposed for wall and or door insulation, and then type W is for a wall here as well. The tile ceiling for the CT, you can see it goes from tile ceiling from one tile to the other, and the vent shafts, model S, the type S. These are great. We utilize these a lot when we're working with hotels. So these are great vent shaft type quiet vent silencers there as well. Here is the comparison for acoustical performance. So you can see you have your noise reduction decibels here for the different types and where your install is. You can also see the different models here. Now again, these are not just, do not hold us just to these sizes or models. If you have a model and one dimension is different, we can do that. So get with me on that. I'll be more than happy to kind of help you out and get a new submittal out to you there as well. I do want to thank you here for just the webinar portion of this, but what I would like to do is spend about the next 5 minutes, if that. I know we're on a time frame here. Spend about the next 5 minutes here going over the snap tool and then the virtual tool to kind of give you a teaser on that. Contact me via email, and I can actually send out the webinar, and I can also send out to you a nice link of how to actually utilize both of the tools. So let's get to the tools here and slide this over. And you can see that here is the snap tool. When you get to this, you're going to be kind of coming into, let me log off here. You can see register here for this. It's very quick. It takes you about a minute or two to register for it. You can save it for your login. And once you do, you're going to come to this screen. You just basically click on new project, fill out the information on, and just follow on. It literally walks you through what to do step by step. I've already got a training one set up here, so we'll kind of click into that. So that way you can see how this works. You can either do a room side calculation or an atmospheric calculation outside. Click on the house and the tree, and you'll be able to change the information. Same thing with the room. You can click on the cute little room there. You see this is the information that is defaulted. I have changed this from 39 to 39 though, and I have gone to, instead of an NC rating, to a DB rating at 81. For the example that we're going to use, this is what is being, this is what is needed here. So the grill width and height will be the same as the duct and or silencer for the snap tool. Click OK. What you've done is you've set the room parameters within the tool. The next thing you want to do is, if you have the fan criteria, the cut sheets, and they have the 8 octave bands, what you can do is you can take those 8 octave bands, which I have done here, and you can put those into the actual tool. So now you've then set the tool for not only the room performance, but also in coordination with the actual fan. If you don't have the fan, you can click on the manual entry for the pull down tab. We have multiple different ones through here. Let's say we go for backward centrifugal. You enter in your CFM, your inches water gauge, and it will then populate the different octave bands for you. We are conservative on that. We've had this tool now since 1970, so we've been able to acquire a lot of data, but that is kind of where we're at right now within that. So if we look at that and you click OK, we have a starting dBA at 90. We got to get to 81. So what you do then is there are many different segments through here, right? What we're doing is, for this specific example, we are going to be applying a silencer directly to a fan, and it's going to be the exhaust. So it's going to be right up against it. In this area, we know the length, we know the width, we know the CFM. You do not know what type yet. So what I typically always say is quick pick. And it will either give you 1, it could give you 10. And so let's basically click OK, and you'll see that these are designed, and you see it starts out with pressure drop here, the model, and the length. These will always populate from length, from shortest to longest. Now, in this specific example, the ML was selected, but I had to change it to 3 feet because that's what was asked for us here for the example to do. And you can see here is your now criteria. Click OK. And we are at 11 dBA plus. So it's basically a pass-fail. Pass means it's green. Red means it fails. So look down here is that as you go through this, you're going to see here's your silencer and all the performance characteristics. Here's your insertion loss values, your system attenuation, sound power loss after your silencer, your self noise,